Hello everyone, I'm Dr. Shruti Pandey from University of Louisville, and today we are taking a very important topic which is electrical power. So the power in electrical engineering is broadly classified into real power which we also call as true power, or we can also call it as active power, and the next one is reactive power. Right. So the real power, active power, or true power is because of the element which is resistor, and the reactive power is because of these element inductor and capacitor. So this real power is basically responsible for the work done. So just in case of a fan load, like a fan is there, and there the active power is how the active power is contributing the motion of the fan. The fan is rotating, that motion or the mechanical work done is the thing which we call as active power, or and therefore the definition is like it is responsible for the work done. And what is this reactive power doing? Let us say that the fan has an inductor inside it, and from the supply I am giving some current into it. So this current is creating a magnetic field in the coil or the inductor coil. This magnetic field causes certain flux, and this flux causes the EMF, which is as per Faraday's law, it is minus n d phi by dt. So this all process, the creation of magnetic field, this is because of the reactive power. So we can write it as here in case of inductive load or a fan load, that it is responsible for creating the magnetic field. So that way the both of these power, the real power, the name, as the name signifies, right, the real power, the true power, or the active power. So this is the main power, right, and it is responsible for the work done, or we can say that in case of fan it is the rotation thing or the motion, right? So this is what real power is, and reactive power is equally important in these kind of loads, because when the magnetic field will be created, then after that motion will be done, right? So this reactive power is as important as the real power and active power is. Okay, now so by this, one more thing I would like to discuss here is the real power is denoted by an alphabet which is P, and the reactive power is denoted by the alphabet which is Q. The unit of real power is in watts, right, or you can say kilowatts, and the reactive power unit is in VAR. This is voltage ampere reactive, right, or we can say that kVARs, right? So these are the two kind of powers. One more power come into picture, which is apparent power, right? So what is apparent power? Apparent power is basically the combination of the real power and reactive power, and this is signified by letter S, and the unit is kVAs, or we can say VAs. This AS is the amperes, 5 amperes, 6 amperes. So this S is. So yeah, so now we know that there are three kind of power. Electrical power has three component. One is real power, one is reactive power, and the third one is apparent power. Okay, so now we can, if we want to know the relation between the real, reactive, and apparent power, that relation we can see with the help of this power triangle. So I'll write it here, that there is a thing which is known as power triangle, and power triangle is nothing but this. Okay, so this base thing is the P, or the real power, or the power because of the resistive load or pure resistor, and it is, the unit is in watts, right? And this vertical component or the perpendicular thing is Q. I'll write it here that it is real power. This is the reactive power, right, because of L and C, and this is because of R. This reactive power, the unit is kVARs, or if I'm writing it here watts, I'll write it as VARs, and this component is apparent power. right? And the unit is in VAs. Okay, so what's the relation between this? We'll apply a simple Pythagoras theorem here, which is S square is equal to P square plus Q square in this triangle. The other thing, we can also write it as like this is base and this is hypotenuse. So we can write it as that base by hypotenuse. What is base by hypotenuse? It is cos theta. Okay, so the active power or the real power can be written in terms of this apparent power, which is P is equal to S cos theta, and the Q or the reactive power component, Q can be written as this will be perpendicular upon hypotenuse, which is Q by S is equal to sine theta. That way we can write Q is equal to S sine theta. So this is the reactive component. This is the reactive component and this is the active component. And when we are going to, like, if we'll square P, this equation 1, and if we are going to square equation 2, P square plus Q square will be at left hand side. At the right hand side it will be S square, and in bracket it will be cos square theta or sine square theta, which will be 1. So that way we can get this equation back. Okay, there is one more thing which we call as power factor. So what is power factor? Power factor is represented by cos theta. This is what power factor is. What is power factor? The physical significance is this. Like, this is a voltage waveform, and we say that with a different color, maybe with red, we'll say that this is a current waveform. So the difference between these two, that theta angle, this is what power, this angle is power factor angle, and the cos of this angle is theta, power factor. So we can write it as that this is power factor angle, and cos of this theta is what power factor is. Okay, so this is also one of the important components. So I'll write it here. This is V, this is I. Other parameters or other important things which are which are required before solving the active, reactive and apparent power questions is this thing is also important. What all? Like, yeah. So the power, the P, the active power thing, the formula for the active power is EI cos theta, right? Where E is VRMS, I is IRMS, or I can write it here. It will be VRMS, IRMS cos theta, right? The reactive power, formula for reactive power is reactive power is EI sine theta, or we can write it as VRMS IRMS sine theta. Okay, and the apparent power is E into I. No cos theta, or the value of cos theta is 1 here. So this is VRMS into IRMS. Okay, so if the question is given in this form, Vt is equal to Vm cos omega t plus theta, right? If the question is given in this form, then first we need to take the value of RMS from this equation, which will be Vm by root 2. But apart from this, generally if in the question it is mentioned that a 120 volt 60 hertz or 50 hertz source or a generator or a motor, anything like written like this, those values are always the RMS value, right? So if in a question it is directly given 120 volt, so that you have to consume as an you have to consider as an RMS value. But if it is given, if the voltage source is given like this, this is Vm. I'll write it again. This is nothing but Vm. Okay, so if in a question something is given like this, or the source of voltage is given in this form, then this is the maximum value, and you need to find out the RMS before making a power triangle or before calculating P, Q and S. Okay, so yeah, that's it. These are, yeah, one more important thing is left. So just for the practice, we can see that how will the power triangle look like if we are talking about the lagging power factor thing. So it is that device with lagging power factor. So it has a P component into it and a Q component into it and S component into it. So you can see that in lagging power factor, the Q is positive, and in leading power factor, the Q is negative. So what is this lagging power factor? So there's a quick trick that if we'll write as civil, right? So in civil, if I take only these three, which is C, I, V, in this case, I comes first, yeah? So I leads the voltage. I comes first and then the V value is there or the V voltage is there. So in this case, we can say that it is leading. So in case of capacitor, the current is leading the voltage. While if we take these three, the other part or the other half, it will be VIL. And by this I can say that in case of this inductor or inductive load, I'll write it as inductive load, voltage comes first and the later is current. So here I can say that current lags the voltage, right? So that way in case of capacitor, current is leading the voltage, and in case of inductor, the current is lagging the voltage, right? Because the current comes later and the voltage comes first. So that way we know it that whenever we say that it is a lagging power factor, so lagging power factor means we are talking in terms of current, that the current is lagging behind the voltage. And what is that component where the current lags behind the voltage? It is inductor, right? So whenever there something is like this, that device with lagging power factor, we know that it is talking about inductive load, or the inductor component is dominating in this case. There might be, and yeah, here a P component is also there. So if this load is something or this device is something like this with an R value and with an inductor value, right? So because of this, the power which exists is P power, which is this, and because of this component, the Q power, which is this. Okay, so I'll just redraw it so that no confusion could be there. Okay, so this is this R and L, right? So the power due to R is P and the power due to L is Q, and that Q is also positive. Okay, now here we see that it is leading power factor. So we know that where the power factor, in which case the power factor will be leading in the case of capacitor. So this is a capacitance dominating load, right? Capacitive load. It has an R component into it, R, and a C into it. So negative Q or negative reactive power is because of Q, and P is because of the resistance, right? Or the resistor which is here. Okay, so next we'll see purely resistive load. So we know that P active power is because of the resistors, right? So Q is 0 here. In case of purely resistive load, we only have P and Q is 0 here. Whereas in case of capacitor, when it is a pure capacitive load, whenever there is a pure capacitor load, no P is there, right? P do not exist because P is the active power or the power which exists because of the resistor. So here you can see that P is 0 and Q is negative, right? So you have to remember this thing also, that Q is positive in case of inductive load or lagging power factor load, and Q is negative in case of capacitive load or leading power factor load. I'll write it as capacitive load. Okay, so this was all you should know regarding the active power, reactive power, and the apparent power. In the next video, we'll take a very basic question regarding this and we'll cover almost all components, finding out active power, reactive power, apparent power, making a power triangle, and solving the equations. Okay, so that's it for today's or for this video. Thank you.